Hello there. Today we are going to build a Wordle. Of course we are going to be a Wordle with Datastar. For those of you who don't know the Wordle game, let me show you how it works. You see here that I have 5 tries to guess a word. Green letters means that the letter is on the right position on the word to guess. No yellow letters. I am going to lose the first game. Patate. Rad. No, the word was papaya. It is going to be a Wordle in French. Let me show you, I just have to reload the page to try another one. Chant. So, we have a C in yellow, that means that the word to guess has a C. Here. Wordle boss. Wordle boss, no notes. How are we going to do it? We can start with the front-end reactivity. And I will show you the signals. This fetching signal is an indicator, don't worry about it. We see that we have two signals, current and squares. And you see when I type letters, that current goes up or down when I erase, and that squares is going to be the squares, the letter I type in the squares. Very simple stuff. Not so simple actually, because we don't want current to go over 6. If I keep typing, I don't want squares to be over 6. And when I erase, I don't want the erase signal to do anything when it erases. So we are going to use some JavaScript to control the signals. If we take a look at the HTML, we can see that on the main element, we have a data on key down with the window modifier, because I want to listen for this event on the window object. And we have, whenever I press a key, response equals react to key with the event and some signals. What is react to key? It's just, you see here, a custom JavaScript function that you can write. This custom JavaScript function checks that the key is in the alphabet, handles erasing keys, and there's submitting the squares. So if the key is in the alphabet, we add it to current, and we are going to return current. If the key is backspace, we decrement the value of the current signal and we erase its position on the squares list. If the key is enter, and if current is 6, meaning that all squares are completed, we return OK. So we kind of have a response code and some information that we are going to apply to the signals afterwards. But the main stuff is this. How do you use a third-party library or a third-party JavaScript with Datastar? Very simple. Just import it, and then if you, for example here, define the function, you can use it in any data on expression. If we take a look at the rest of the code, we are going to deserialize the response. So we take a look at the response code. In case it's okay and all squares are completed and we want to send to the server what the user typed. We want to adjust the value of the signal current. So we have kind of a body response here. And we want to adjust the value of squares. Notice here the special JavaScript syntax to recreate the list. This is not perfect, but it works. You can see that it works. And with all just 3 lines, I can handle the event of a user typing, modify signals, and make a post request to the server if some conditions are met. So you can add very complex behavior to your signals, provided that you just write it, import it, and use it with Datastar. You see that it stays really elegant. We conclude our investigation on the front end. You can see on the main element that we have some style, grid template rows equals repeat 6 1 fraction. This is because we are going to have an editable number of lines. I can change it in the server if I want it, and the server will apply some style to this element. We can see that we are using data at current with the current signal. So for example, this square has current if signal current is 0, and this square has current if signal current is 1. And you see that I use it to apply the yellow bordering, indicating to the user where he's typing. For the text, I just use the value from the list in the signals, the list squares. And there's not much to it. You have a really nice front end up and running just with that. We are going to see the backend now, and afterward some CSS tricks, as always. For the backend, nothing really special if you've been following the videos. The classic stuff from Quart and Datastar, TinyDB for the database, Redis as our PubSub manager, a list of words to choose from because it is a word game, and choice to put some randomness to it. We initialize the app, we initialize the Redis client, we initialize the number of lines. Let me show you. I can put, like, for example, 3 lines if I want it to be really hardcore, and I just have to save, and when I reload, 3 lines. Let's go back to 5. Alright, I put the lines back to 5, I reload. We have a function to determine if the game is over. If all lines were filled and the word was not found, it's a loss. If the word was found, it's a win. And if the game is not over, we return nope. So a little helper here. The main view, we are going to see this afterwards. And before any request, we are going to link our user with a database entry. So if there's no database entry, we insert one by choosing a random word, putting current at 0, putting the list of lines, the list of atoms from the user as an empty dict, and link to this database in the session. What I'm gonna do is on the index clear the session. That way when you hit refresh, I clear the link to the database, so a new database is created and a new game can go on. So that's the way I implemented the new game mechanic. You can do it however you want, with a button, with whatever you want, but if you just want a new game, just clear the session from the database link. And because you have a before request, you're gonna get another one eventually. Now we get in the real stuff, the main function. What we are going to do is retrieve the database, subscribe to the database. So if any event change, my generator that I define here, you see, is going to wait for changes on this database. If there's any change on this database, because we have an open connection thanks to Datastar use of SSE, we retrieve the new data and we generate the corresponding HTML. And you see after that we are going to reset the signals that we saw beforehand of interactivity and merge the HTML. Building the HTML is going to be very easy, barely an inconvenience, because we have the list of lines that we are going to build. We have the current line which is active. So we start with the main element. We are going to do a big morph on main as usual. So ID main and Datastar will take care of the rest. We can use some inline style to adapt to the current parameters of the server. So for example, here I want the grid to accommodate to the number of lines that I want. We add our behavior for capturing events with the data on keydown, and then we build our lines. If we are building the current line, we add all the front end stuff to it. So the data at current, and the data text square. And if it's a normal line, we get it and we add them. Two things that you can notice here. The first one is the style, but this is going to be for the CSS tricks later. And the second one is that we are storing two things in the database, because we are going to store the letter and its color. It was very simple. Let me show you in the database. For example, for this game, so the word to find was vendre, and then I stored every attempt. So OK, d'accord, gray, 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 yellow, because the D was somehow correct. We end with a little indicator, so a little SVG to indicate that the request is flying. This is this stuff that you're seeing here. indicator. Oh, the request is flying too fast. The last thing we have to see is the attempt. So whenever my little React to key script makes the post request to attempt, we are going to, because it is a post request, just retrieve the signals on the page. So the squares is going to be the square signals, so the input of the user, what's interesting. We are going to get its database ID, and if there are any squares, I look for differences and I add them. So I add the letters and the corresponding color. And what I do after I've done all my checks or my game logic, I just publish to the Redis client. I publish to the database, ping or whatever I want, and we've seen that on the open main connection we are waiting for changes to the database to move. So whenever I change it, I ping is the string database ID. So I ping, yeah, I touched this database. I updated the game logic. Whoever is listening, please make a new HTML view. And this is exactly what is done here. Finally, you're going to wonder, how do I achieve this really nice effect where the letters flip one by one? And it is actually really simple and pure CSS. One thing I should mention here is that the word list is actually just 47 words long, and by now I know most of them, so yeah. Also, how do I change from this screen to the end screen? Yeah, if on the word did 2 tries or wrong, the word was blah blah blah. It's really simple. Just after checking the state of the game, so checking for a game over right here. If, for example, the user won, I just wait 3 seconds for the animations to complete and I send another fragment. Yeah, if on the word. Because the connection is still open, I can send whatever I want. I could send a lot of other stuff, but see that this works really fine as well. Because Datastar disconnects and reconnects automatically the connection, you see that when I tab out and tab in, Datastar reconnects, send the HTML from the database, wait 3 seconds, send this because the game was over after the check. But sorry, back to the animations. We want them to do this little flip to change background, so we are going to use CSS for this. You see that we give to each square the animation rotate. So rotate is defined as these little flips for 0.2 seconds forwards, because we want them to stay that way after, and we are just going to give delays incrementing by steps of 0.4 seconds to each one of them. And actually I can give this animation to every square. I don't really care, because if the square doesn't change, the animation is not going to play. So every square here has this rotate stuff, but only because this line is changing, it's going to do the little flip. For the background change, again, some really simple CSS. I just say that every square should have a transition of its background of 0.2 seconds, so the same time as the flip with a delay, and the same delay as the flip. So after 1.2 seconds, the fourth square is going to rotate, change its background when transitioning to its new state. And because we have all these delay steps, it's going to give this nice little flow to our application. And I think that's it. So you see that it was, again, really simple to do a Wordle in Datastar. Open a connection, subscribe to a database entry. Whenever there are changes, stream the view that you want. Do some controls, fine-grained controls on the signals with imported JavaScript, and then have fun. I mean, it is really fun to play. I am going maybe to do one last game. Ananas. Pineapple. So we have an A, an N. Naître. Attends. So the E and the danger. No, the R. So okay, the R is here. The N is here. Yay! So that's all for today. It's really simple. As usual, you have the code on the description if you want to follow. Leave a comment if you want to see another game, another app, and see you.